Now in this video we'll look at depth first search. This is one of the graph traversal method. This is similar to pre-ordered traversal of binary trees or trees. Let us understand how it works. So for understanding, we should know two terms. First is visited. Whenever vertex is visited, when we have reach, we call it as visited. Second thing is exploring a vertex. Exploring a vertex means visiting all adjacent vertices. Like suppose one adjacent vertices are 2, 3 and 4, visiting all of them. So based on these two things, I will define and explain depth first search. So let us perform depth first search upon this graph. Here I will be writing the result of depth first search and it uses a stack, so I will use a stack also here. Now let us start. What should be the initial starting vertex? You can select any vertex as a starting vertex. So I'll select starting vertex as 1. Okay, 1 is visited. 1. Once it is visited, start exploring vertex 1. So who are adjacent to 1? 2, 3 and 4. Which one I should go? I can go on any starting vertex. So I can go on 4 also, 3 also, 2 also. I will go on 2. Okay, 2. 2 is visited. 2 is visited. Then, what is the next vertex of 1? Adjacent vertex is 3. No, don't go on next vertex of 1. Suspend 1, exploration of 1 and start exploring 2. Then what to do with 1? Push it into the stack so that we can continue its exploration afterwards. Now we are on vertex 2. Start exploring 2. From 2 we can go on 3. Okay, go on 3. 3. Suspend exploration of 2 and start exploring 3. So 2 in the stack. So it means whenever we get a new vertex, we will suspend the old or current vertex and we will start exploring a new vertex. Yes, that is the approach of depth first search. Explore 3. From 3 where I can visit 4 as well as 5. I prefer going on 5. Okay, go on 5. Then what about 3? Push it into the stack. Suspend its exploration. We have visited 5. Then from 5 where I can go? I can go on 6 and 7. So first I will go on 7. 7 is visited. Push 5 into the stack so that we can explore it afterwards. Start exploring 7. From 7 I cannot go anywhere. Then 7 is completely explored. If you have visited all adjacent or there is no adjacent, we say it is completely explored. Then go back and continue the exploration of previous vertex. Where it is? In the stack. Pop out. We are on 5 now. Start exploring 5. Next vertex is 6. Okay, visit 6. Push 5 again into the stack and start exploring 6. From 6 we cannot go anywhere. So this is completely explored. Go back to the previous vertex. Pop out 5. So we are again here. From 5 I can go on 4 also. Yes, go to 4. Push 5 again into the stack and start exploring 4. From 4 where I can go? From 4 I can go on 3 and 1. 3, it's already visited. 1, which is already visited. So this is the first time I came across already visited vertices, so I have drawn a dotted edge there. Now 4 is completely explored. Go back to previous vertex 5. Continue its exploration. From 5, we can go on 7, 6, 4 or 4, 6, 7. All of them we have visited. So 5 is completely explored. Go back on a previous vertex and continue its exploration. Who is that? 3. From 3. Who are adjacent to 3? 2, 4, 5 as well as 1. So 2 from there only we are coming. 5 we have already visited. 4 is already visited. Dotted edge is also there. But 3 to 1 there is no dotted edge. So I will draw a dotted edge here. 3 is completely explored. Take out next vertex. 2. 2 is completely explored. Take out next vertex. 1 is explored. So by the time when you return and go back to the previous vertices, we will find them they are already explored. So once again, I'll explain depth first search. You can start from any vertex you like. Then you have to explore it. And once you got a new vertex, suspend its exploration, start exploring new vertex. This is how we define. So we have seen this result. The tree that we got is depth first search spanning tree. This is depth first search spanning tree. And in this, the dotted edges that we are getting, we call them as back edges. And if you remember, when I was on 4, I have drawn this edge. When I was on 4, I have drawn this edge. From 3, I have drawn this edge. So these are back edges connecting back to the already visited vertices. So they are called as back edges. So this is one of the depth first search. We can have various depth first search traversals for the same graph. Then next thing, I said that depth first search is just like pre-order of a tree. So, but this is the tree, right? This is the tree. It is a depth-wise generated, not level-wise, depth-wise generated. Perform pre-order on this one. So like, but just by moving a finger, we can get it. 1, 2, 3, 5, 7, then 6 and 4. 1, 2, 3, 5, 7, 6, 4. So for this tree, it is pre-order traversal like. The next thing, we will see the analysis. What is the time taken by this depth first search method? So the time depends on the work that we are doing. What we are doing here, we are visiting all the vertices once. So how many vertices are there? N vertices are there. So the time is order of n. So the time taken for depth first search traversal and this analytical time. Remember this, when we write the program may be taking more time because it depends on the data structure that we are using. If you are using adjacency matrix, then it may be n square. If you are using adjacency list, then it may be n. So analytically, we say the time taken is order of n because we are doing nothing, just we are visiting all the vertices once. So that's it. I have explained you depth first search. Now I will remove this and show you various valid depth first searches. So you get the idea how we can perform depth first search in various ways. Now let's perform. I'll write down the results just nearby this graph. First one I am writing, starting vertex. We can select any vertex as starting vertex. So I will select vertex 1. Then from there where I want to visit, I can visit anywhere. So I'll go on 3. Then from 3 I will go on 5. Okay. Then from 5 I will go on 4. Then from 4 I cannot go further because already 1 is visited. Come back to 4. From 4 there is no other route. Come back to 5. From 5 I can go on 7. Okay, 7. From 5 I can go on 6. Yes, 6. Then come back to 5. Right? This cannot be explored further. So this is completely explored. Go back to 3. From 3 I can go on 2. This is also valid. Second one. Starting vertex is 1. 1 to 2. Okay. 2 to 3. Okay. From 3 I can go on 4. From 4 I can go on 5. From 5 I can go on 6. From 6 I cannot go anywhere. Go back to 5. Come on 7. This is also valid. Then one more. Third one. I'll start from vertex 1. Okay, 1. Then I'll go on 4. Yes. From 4 I will go on 5. From 5 I will go on 7. From 7 I cannot go further. Come back to 5. Then from 5 go to 3. Okay, 3. From 3 go to 2. 2. From 2, this is already visited. Go back. From 3 I cannot go anywhere. Go back. See, 2 back, 3, then 7 already gone. 5, I'm on 5. From 5 I can go on 6. Yes, 6. From 6 I cannot go anywhere. Go back to 5, go back to 4, go back to 1. So how to go back? That stack will help you. Or else you practice this, you can get it easily. It's not difficult. Just you do paperwork by yourself. Do it once. Then one more I'll show you. I want to select some other vertex as starting vertex. Okay, select it. Which one? 4. From 4 I can go to 1. From 1 I will go to 3. 2 I skipped. I came on 3. Yes, I can go anywhere. From 3 I will go to 5. Okay, from 5 I will go to 6. Go back to 5. Go to 7. Then this is finished. Then go back to 3. From 3, 2 is remaining. Take 2. This is also valid. So these are various possible depth first search with a different starting vertices or different order of visiting, and all these are valid. Usually students believe that there is only one method, one answer we get. No, you can get different answer. See again, the answer that you are getting is not important. Visiting all the vertices is very important. You should visit all the vertices. So that's all about depth first search method. We will see a program or algorithm on this one.